This is a short video explaining the solution to the Networking 1 Week 5 lab. We start with a pre-configured lab using Packet Tracer, where we have two PCs connected using two routers, and a series of static routes have been added to both routers to allow PC0 ping successfully to PC1 and PC1 to ping successfully to PC0. The requirement of this lab is, first of all, to add a third router and to add a laptop into the configuration, identifying two new networks, LAN4 and LAN5, and configuring static routes on each of the three routers, which would allow laptop 0 to successfully ping PC0 and PC1. The first step to solve the lab will be to complete the addressing table. Within the lab, I've identified all of the IP addresses on all of the interfaces for the router and for the laptop, and also for the R1 router. So I'm just going to fill those into our addressing table, where I've already used the details that were used in lab4 to configure all of the other components. On router 1, we have a new interface which is on LAN4, and the IP address of that is 172.16.4, which is the new network, and the IP address associated with serial 031 is .2. All of the networks we're using are Class C, so all of the net masks will be the same for this lab. For R2, we have two interfaces. One is the interface that connects directly to the laptop, and we've identified that as 172.16.5, which is our fifth network, and the IP address associated with that is on our fast Ethernet port here, and if we read off the network as 172.16.5, the IP address allocated for this interface is .1. For the serial interface on router 2, we have an IP address which has to be on the LAN4 range, so 172.16.4, and the IP address we're allocating is .1. 172.16.4.1 with the following net mask. The laptop is also on LAN5, and the IP address associated with this is .254. The IP address for the laptop is 172.16.5.254. This is the net mask, and the default gateway is given as the next interface that would be able to potentially handle all traffic that is sent from the laptop where we don't know the destination network. So we send all traffic that isn't on the LAN5 network to the FA00 interface, which is the following IP address, 172.16.5.1. At this point, we've completed all of the addresses required within the system, and our next step will be to configure the laptop and configure the router, and then configure each of the static routes between the system. Next, we're going to add the components of Packet Tracer using the starting point, which is the concluding point from lab 4. This is a fully configured network. First of all, we need a new router, and next we will need a laptop, shown here. Next, we will require cables to connect the systems. For the laptop connection to the router, we will require a crossover cable that will be connected to the fast Ethernet port here, and will connect to the fast Ethernet port on the router. Before we can add a serial cable for router 2 connecting to router 1, we must first turn the system off, look for an interface as shown. This will provide two serial interfaces. We can reboot the system and allow that to come up. Next, we will select a serial DCE cable that will connect from serial 030, and that will connect to router 1 on serial 031. Now the system is fully connected, we need to configure both the laptop and the router 2. The next step is to configure the interfaces on the laptop and router 2. I go to the static IP routing for the laptop and set the IP address 172.16.5.254, and the net mask is a class C. The default gateway 172.16.5.1, which is the interface on router 2 to its fast Ethernet, and I save that. Next we'll configure the router. I'm going to set the router hostname first, and set the host name as OR2. Now that we have the host name, I'll set the interface for the fast Ethernet. So interface FA0/0. I'll set the IP address, and the IP address for this is 172.16.5.1 with the correct net mask set. And we'll bring the interface up using the no shutdown command. And we can verify that that is now installed in the routing table. We'll use the show IP route command. As we can see, we now have a directly connected network 172.16.5.0, which is the LAN network between the router 2 and laptop 0. The next step will be to configure the serial interface between router 2, let me just show it here, router 2 and router 1. So interface serial 030. We set the IP address, and the IP address for this is on LAN 4, so it's 172.16.4. We've allocated an IP address of 1. We'll set the net mask as follows. I'll bring the interface up using no shutdown. Now at this point we can see that the interface is still not fully up. We need to set the clock rate 64,000. We'll still notice that the interface won't come up until we configure the far side of the connection on router 1. At this point we've concluded the configuration of router 2 and laptop 0, and I will bring the second part of this line up. On router 1 we will now configure the serial 031 interface. Type in interface serial 031, and we will set the IP address to 172.16. This is on the .4 network, and the IP address allocated for this is .2. We will bring the interface up, and now we can see that the serial line has in fact come up. I'll just check the routing table. On the OR1 router, we see we have a connection now to the 172.16.4 network directly connected over serial 031, and that interface is currently up and running. The next step is to examine the routing tables on each of the routers to understand what is currently configured before we add any further static routes. If we have a look at router 0 and do a show IP route, we can see that router 0 is aware of the following three networks: 172.16.1, .2 and .3. So any traffic that is destined for systems which aren't included in those three will in fact have the packets not routed but in fact discarded. If we have a look at router 1, we can see that we have currently configured 4 of the 5 existing networks, so we're still one short. We couldn't route from this router to 172.16.5 for example. If we have a look at router 2, have a look at the routing table, we only are aware of two routes, or two networks, 172.16.4 and 172.16.5. The next step would be to add routing information or static routing information to each of the routers so we can fully identify and route between all of the networks. I'm going to start with router 0. We have 3 of the networks configured, so let us add static routes which would tell us how to get to the remaining 2. The important thing to know is that when I set a route on router 0, what I'm saying is that the serial interface, or the interface that's required to access those routes, is which interface. So in this case we're going to have a look at this serial interface is the direction that PC0 would send all packets for networks 172.16.2, 3, 4 or 5. So I will add an IP route, and the route will be for the network 172.16.4.0. We identify the net mask as follows, and then we identify the interface to send traffic that is destined for that network. It will be over serial 0/3/0. We also want to add a second static route which tells the router 0 where to send traffic for the network 172.16.5. So I will add a second route, 172.16.5.0, over the same interface. Examine my routing table. We can see that this router is now aware of which link to send traffic destined for any of the 5 networks in our network. If I go to router 1, I can do something similar. This router is aware of networks 172.16.1, 2, 3 and 4, so clearly we need additional information to handle traffic which is destined for the 172.16.5 network. We will add a final static route, and that will be as follows: IP route 172.16.5.0, and we will send all traffic destined for the 172.16.5 network over this serial interface, which on this system is serial 0/3/1. And we can see that all of the networks have now been configured, and we've identified which interface to send network traffic from router 1 to reach the correct destination. Finally, we need to configure the static routes for router 2. We currently only have 2 routes, which are the directly connected routes, so we now need to add routes to identify where to send traffic for 172.16.1, 2 and 3, and in this case all traffic which is sent from laptop 0 to router 2, which is destined for LAN 1, LAN 2, LAN 3, or 172.16.1, 2 and 3, must be sent over this serial interface. And there are the 3 static routes we'll now add. So we send or derive a static route for the network 172.16.1.0. That will be sent over the serial interface 0/3/0. Next, I'm going to send network traffic for the second network over the same interface, and then finally for the third network again over the same interface. I can now have a look at my routing table and see that I now have somewhere to send traffic for all of the networks in my system.